Hello, 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 and hello, everyone. Let me check if I'm live on all platforms. Awesome. It seems like we are live on Twitch and on X. Let me just also see if we are live on YouTube. Awesome. We are live on all platforms. So, hello, welcome again. I am Aditya Bansal, and the agenda for today's stream is learning Python. Obviously, it's not possible to learn everything in a single day. So I'm on a mission to solve some lead code questions and learn more and more along the way. One of the major goals of mine will be to solve a lot of lead code questions and see how I can make progress there. Another thing would be like reading documentation by Python, because that has proven to be great in past, and I think it will be helpful for us in the future as well. I know I have a lot of background noise. That's common here, so please bear with me. I am adjusting some settings. Let me just fix that. 1 second. Okay, so just let me adjust this. And let me see, YouTube is experiencing some lag. Okay, I'm streaming after like a bit of a time, so it's kind of new again to figure out things. Let me see if I can. Okay, so we will be working in two modes today only, I guess. One will be in our full talk screen, and another will be this small split because the other option is not working very well. Let me see if I can get it working, but it's currently looking like this. I'm in a rectangle instead of a proper square, but I guess we can make it work. No worries there. I really wanted it to properly work, but for some reason it is not working. I can just put the chart up here and see if that works. Yeah, so I think I am able to like fix this face ratio now. So it should be better. So I think this is okay. So my goal is to basically solve some lead code problems. I started with some things. Let me just open up my queue. So Leetcode has this very helpful like study plan thing. And I found that the most helpful questions are the top interview 150 questions. So I just, thank you very much. And the top 150 questions, like these are the most helpful ones. If you basically solve these, we are good to go. I have solved the previous ones. They're like array string and then two pointer approaches and then sliding window. There are some hard ones which I think like I will leave this for the last, because I tried looking at some of the solutions, but they are still a bit more confusing. So I guess it's better to keep up the pace and cover more topics rather than going into details about like every single thing. So continuing with the study plan, I guess we the next one will be valid Sudoku. And for this one, uh, let's just get started. Like I think I have solved this one before, but at that time I was coding in C++. So approaching this from Python's point of view is a new thing for me. So let's see how I can apply those data structures here. Our question is like just to determine if the Sudoku board is valid, and we have to just check if it is valid, not to like solve it completely. So that simplifies things. Only the filled cell needs to be validated according to the rules. Each row must contain the digits 1 to 9 without repetition. I think that will be easy to check. We can just go row by row. Each column will also be simple to check. Like we can just go column by column. And each of the 9 3 by 3 sub boxes of the grid must also contain those things. So for that, I think we can do we have to figure out a way to iterate 9 times. Then like basically in the we will go the first block, second block, third block, and then again we will go first, second, third for this, and then again first, second, third for this. So a coordinate system, something like I plus this, I plus that. So currently the solution I can think of is like first we iterate for the rows individually. So this will be 9 times. And then let me also just do this. Just give me a second. Yeah, sometimes the hard ones can be like actually be easy, and the medium ones are actually marked as hard ones. So they flip the script sometimes. I think this is also like marked as medium, but I would consider this as like a easy problem because we have a straightforward approach. Like we can brute force this. We just check all the rows first, then we check all the columns first. It like iterate 9 times and 9 times. Yeah, exactly. This is like a easy medium. And then for like each of these blocks, I would say we can iterate I is equals to 0 to 3, and then j is equals to 0 to 3. Like this will be our offset. We can say for each of the, yeah. And like again, this, like exactly coding this, we'll see how that goes. But let's try the brute force approach for, and to keep the track of like all of the numbers that we have seen, I think we can just use a set and see if like if this number has appeared before, then we will just say false, this is not valid. And then if we have not seen it before, then it's valid. And I think it should be a list of strings. Sometimes I struggle on problems where, for a simple example, I first think it's a graph problem, and then I try something, and then for for a very peculiar reason, it cannot work. So I need to start again. Yeah, I can totally understand it, and I think another reason why this list is like very helpful because we already know like what type of problem we are solving. Currently, we are like tackling matrix problems, and they are like you just iterate most of the time, and we have a separate section for graph, so that simplifies things at least like for practice. Otherwise, like you're going in with the same mindset as like an interview, and that can throw things off. So it's just to keep things simple, because obviously when we get used to this stuff, then we can just attack the problem in the interview, and that makes things so much simpler. So I guess I will just go with row uh, in range 9. We can just hard code this for now, and then for each row we also have to tackle the column, and range again 9. So I guess this is 9 into 9, so we are doing like 81 operations in total for the rows only. So I guess we need to optimize this as well, but let's brute force this for now. And then we can have like a row set, which is like just a set. And then if our board, uh, row and then column has in our row set, then we can just say like return false, why bother? Else we can add it. So then row set dot add board row column, and that can like figure out like how to approach this. Basically, if we have it in the row set, then we can say just like return false, otherwise add it to the board. And also this will be we also have to check if it's not dot. So we also have these dots as strings, so we also have to parse and remove those. If board is equals to is not equals to the dot, and it is not in. So if it is a dot, then we don't care. Or we can like, to keep the logic more simple, we can go if board row column is equals to a dot, then we can just continue. If the board is in row set, then we say false, else it is okay. I think because we are iterating through this. So if we were to just like tackle it as because we are already iterating through this thing once, I think we can tackle the columns check as well at the same time. I don't wanna, what do you say, repeat this loop. So instead of having like a row set and column sets differently, I think we can have like row sets as a dictionary, and each of those dictionaries will have like a separate row set. So row sets of row is a set, and then if the row sets a row, so this set has this element, when we return false, we can also check if this element is in the column sets. So we can also create a column sets. Column sets can go in, and for this we'll go by column. And for this, I think we'll have to add new sets beforehand, because I don't want to like create a column set every time we go on a column. So we can do for row in range 9, create a row for just, we can do I in range 9. Row sets I is equals to a set. And then we can also do column sets I is equals to a set. So now we already have the sets. And then if the element is, if the we can just call it element. If this is this, then we can go element, and we can continue. And otherwise, if this element is present in this, or the element is present in column sets call, then we return false, like it is present somewhere else. Otherwise, we have to add it in proper locations. So row sets dot row we add the element, and then for columns, we also do col sets column dot add the element. So this checks like just the rows and columns. Now for the matrices, sub matrices, for that we can do you can iterate from 0, 1, 2, 3, 0, 1, 2, 3, and then mark this at offset. But can we have that approach? Because currently, if I look at it, I can have to go like 0 and then 9 times. Then I can just have X offset and Y offset are the two things I'm looking at. So let's just code that for X offset in range 3, for Y offset in range 3. So for each of these X offsets and Y offsets, this will go 0, 0, 0, 0, 1, 0, 2, and 9 times total. And for each of these, we can create a new set like, what are they calling it? Sub boxes. So a sub box set, we can call it. It's a brand new set. And for I in range 3 and for j in range 3. So this will also iterate like 81 because we are going over each of the elements one time. So this will be like 81 iterations. And again, in this one, we were also going, this one was 9 iterations only, and this one is 81 iterations again. So no matter what is the Sudoku board, we have O of 1 complexity basically. If the Sudoku size increases, then these hard-coded numbers don't make sense. But currently, I guess like we can solve it in O of 1 every time. And with each of those, we will see if we'll again extract the element. We'll go element, and then we will go I plus X offset, and then Y plus, sorry, J plus Y offset, and that will give us an element. So if you think about it as our X offset is 0, 0. We are starting here. If we add, then we get 5, 3, and then this, and we will complete this set. Then we will get an offset of X of 1, Y of 1, and then we will have this whole block covered. And then we'll move to this. Then each of these will be covered separately. And for each of those, we have a separate set. And similarly, for each of those sets, we are extracting the elements. If the element is a simple dot, then we continue, and we can say else, elif, that the element is present in sub box set. Then we just return false. Else we add that element, into the sub box set. And then at the end, if we reach the end, then we can just return true. We can also improve this by using elif, but then the continue doesn't matter that much, but it's okay. We have this thing. We can also write pass here because we only have else if statements. So our logic currently, I think, makes sense. We have two dictionaries. We are checking all the rows and columns, and then we are checking for each of the sub boxes. And if everything is okay, then at the end we return true. Let's try to run this. Okay, we made some mistake. So let's see where we are making a mistake. We returned false. It should have been true. Okay, so if element in this, let me just see where we are returning true. Print. This is like very stupid way to check it, but I like to do it. Checkpoint A, checkpoint B. That's like the easiest way to check where you're returning. So we are reaching checkpoint A, so we are not returning here. So our rows and columns are saying that okay, it's fine. But our set, this set is not properly working, which I guess like this is a bit more complex logic that I just went with it. So let's see. Uh, we are getting elements, and then let's just maybe rent for each I and j, we get x offset, y offset. So let's rent offsets x offset. So like I want to trace in which box we are making a mistake. Let's run it. So we go to 0, 0, 0, 1, 0, 2, and in the second one, so in this box 847, we are saying that, okay, the element is already present and we don't want that to be repeated. So let's check what is happening here. We can just try printing the elements. And we can end with space to save some space. So for our first one, we got 5, 3, 6, 9, and 8, which is correct. For the second one, we got 3, 1. So this is incorrect because I don't see anything that resembles 3, 1, 8, 9, 8. So this is where we're messing up. 0, 1. So x should be 0. Okay, so x offset needs to be in the uh, jumps of 3. So it should be, currently it is taking this block. And we are supposed to jump here. So it should be, it should go from 0, then 3, and 6. So we are supposed to go from 0 to 7 in jumps of 3. So it will go from 0, 1, uh, 0, 1, 2, 3, and then 4, 5, 6. So if I get this correctly, I will get 0, 1. Let's try running it. Okay, so I got, yeah, 0, 0, and then I also have to fix the y, but like 3 and then 6. So similarly for this, we'll go 0, 7, and then 3, so that we get the correct y offsets as well. And then we get start from 0, 0, this place 0, 3, 0, 6, and then we start from 3, 0, and then we start from 3, 3, then we start from 3, 6, then we start from 6, 0, 6, 3, and then 6, 6. And this should work correctly. We are reaching checkpoint B. We can remove the print statements and run it again. Submit it. And we was able to solve that. Now we have to figure out like how to make optimizations, because I think this can be done in a little bit more simpler way. Before I jump to solution, let me just brainstorm if I can come up with something. Uh, will it be possible to store everything in a compressed way first? We have the columns, we have the rows, but there's no way to subset it. Uh, I guess this is like we have to iterate through the matrices and the rows and columns separately. But if we go from like creating subsets and then combining them, I think the time execution will be the same and it won't make that much of a difference. Uh, let's go with the Python solution. They have a separate function for each of those things, and they are doing exactly what I was doing. They are jumping 0 to 3 with 6. They are checking if the square is valid or not. Yeah, just in a list comprehension way instead of like a whole uh, extended code. And then is unit valid? They have a separate function for is unit valid, and that is just checking. And then for that, they are doing for I and I unit 1 if I is not 0. So each unit is, I guess, a row or a column. And then they have a common function which is applicable on both. So we have a zip and then this. So I think to understand this part, like I am not 100% sure what this is doing. So we can take it to Grok and ask it to explain it to us. It's like a good chatbot to give a detailed explanation. Like I find Grok very useful for giving detailed explanations. I am solving a Leetcode problem to check if the Sudoku board is valid or not. I came across a solution and I want to understand how understand what this line does and how it is being used here. Give me a detailed explanation of what is being passed to the is unit valid function. So we'll let Grok do grokking and see what it comes up with. Okay, so Grok has an answer for us. It's for line is a concise way to iterate over the columns of a board, which is this. Let's break it down step by step. So how do we say it's like going over the columns versus the rows? Because I think it's doing the same thing. Okay, so for board, it is doing just rows, and then for zip, this is for columns. That's like a nice new thing that I learned, that you can just do zip and then you can do star board. I want to break down of that, like what does star do? It's a concise way to iterate over the columns of the board, which is 9 by 9. Let's break it down step by step, how it relates to the isValid function. The board is a list of 9 lists, where each inner list represents a Sudoku grid. For example, the simplified 3 by 3 board for illustration might look like this. Yep. Here board is this, and accessing columns directly isn't straightforward because the data is row oriented, correct? So to get the first column, you need the board 00, board 1, and then this. This is tedious for all 9 columns, so we need a smarter way. What does the zip star board do? Zip is a pre-built function that takes iterables like lists and columns and zips them together, pairing elements from each iterable at the same index. Okay, so at each of the indices, so we have 5, 6, and dot. So it will combine all of those together and create a new tuple, which is like a nice way to iterate over columns, I guess. What does the star operator do is it unpacks, or the splat operation. When used as star board, it unpacks the list of list into individual arguments for zip. So zip star board is equivalent to zip. And then if we wrote each one of them separately, so the star is just like splat or unpacking. I don't see myself personally using that a lot. I think it's just like for argument passing, we might see that, but nothing other than that. This effectively transposes the board and turns rows into columns. So zip star board returns an iterator of tuples where each tuple is a column on the board. And this is how the result looks like. We'll iterate on each one of those. Then the loop body calls this with the whole tuple. If any column fails the check, we return false. And each column is passed as a unit, and then for each unit we create a set. We can pass a whole tuple into the set. We don't have to create iterate manually like I did. So that we can also simplify our code based on that. So we have a row, and then we have column. We are iterating 9 times, and then like total 81 iterations. We can just comment this one, I guess. Let's try. And then for each row in range 9, we can go just create a set named row set is equals to set of boards row. So this will give us the whole row. And then also we can simplify it like just iterate through boards, and then we will have just the row. And then how are they checking if they're safe or not? Okay, so they are doing another one, which is like a unit. And if I, for I and the whole row, I guess if I is not equal to dot, but we have dot, right? So we have for I in, if it is not dot, but we have a dot here. How is this even working? Because ideally, for this to work, the set of this should also not have any dots. Unit is equals to this whole thing if this is equals to this. I don't think that will work because in this set, row set, we might have dots, but in this, we are saying that dot should not be present. I am not sure how that will cross check because one set has a dot and one does not. We can remove dot from this, but let's try. Row set dot remove dot. I think this will make them same. What happens if I try to remove an element from a set and the element is not there? Grok Expert, Grok 4 takes a little bit more time. We can get quick answers, but I think I should let Grok think and give me a proper answer. Remove and discard. If we remove, the element does not error, then we will have a key exception if we use discard. So let's just use discard because we don't want to get an error if the element is not present. So row.discard, and then we'll see this. And now both of these should be the same, and ideally the length of them should be same. So if length of row set is not equals to the length of unit, then we'll return false. Otherwise it's true. And same thing we'll do for columns. And now for columns that we have just learned that we can iterate columns using a syntax, like we first splat it, like give it separate things, then we zip it again. Then we have columns. Now we get access to columns. So now we have columns, we can get column sets, and then we can just put it in set. Then we remove the dot, and then in the column, if it is not 0, then we return false if it's in the column set. So this should work essentially the same as this code did. Let's try that. Boards is not defined. Is it just board? It's just board. Board. It works in the test cases. And it's a little bit slower, but never trust Leetcode time executions because it always varies. But I guess, yeah, like this was a simpler approach. We don't have to iterate over this again. So we can just keep this like as a better approach. But yeah, I think this was a straightforward solution, and I don't think there can be that much improvements on this. They are iterating through once, and then if this is not 0, then we are going in. We are doing some complex math, and then we are returning false, otherwise we're setting it true. Check each row, check each column, and check each sub box. So we have a grid again for each one of these things. So we get a number, and then we get k is equals to divided by 3 into 3 plus j this math. Then we get if it is in the column, row, and then in the box, return false. Otherwise, we set it like it is there. Okay, so I guess this is like a grid of, if we go 9 by 9, then it will represent 1, 2, 3, 4, 5, 6, 7, 8, 9. Like this number is present already, this number is present already. It's just checking that. And if that number is present in that row, we just say that we are already done with that. So for I, we are going like for each row, each column, we are checking if that number has appeared for that row. So for each row, we have 9 things. 1, 2, 3, 4, 5, 6, 7, 8, 9. And they are all essentially set to 0 first. So we have like 9 of these. And they're all set to 0. And then we have same for columns, but at this time, this is like 1, 2, 3, 4, 5, 6, 7, 8, 9, like this way. And then we have for the boxes, which will go and check for each box. So we have 9 boxes. So we can represent like this is a box, and if this has happened, this has appeared, then don't. So, okay, so that gives us an idea of how we can reduce iterations. So I guess we can get rid of all of this code essentially. So we already figured that this was not a good approach. So let's just remove this approach. We'll stick with our simple iterations. Let me just comment this whole thing and we'll just start fresh. So this time we'll be treating like row in range 0 to 9, and then for column in range 0 to 9. And for each of the rows, we have a unique set. Row sets is a dictionary, and then column sets is a dictionary, and then sub box sets is a dictionary, because we can represent each one of these uniquely. We can just go, let me see. So for any of these, we can go I. Suppose this is the thing, 0, 1, 2, 0, 1, 2. So I is 2 and j is 2. Then we can go I divided by 3, and then that will give us 0. And then j divided by 3 will also give us 0. So we have to do integer division. That will give us 0, 0. And then for something like this, which is like 0, 1, 2, 3, 4, 5, 6, 7, 8, will go 8 by 3 will again give us 2, right? Yeah, so that will also give us 2 by 2. So for using these, like all of these numbers in the bottom set will give the same 2 comma 2, and we can use that as a unique string to identify our which box we are talking about. So that way we can remove this whole iteration because we are handling things in a simpler way. And for that, we will go for rows, we are going 0, 1, 2, 3. We will just again create the for I in range 0 to 9. We'll create 9 boxes, like 9 sets, rows, sets. I is equals to a set. And then we'll do the same thing for column. Column sets I is this. Now we have to create set for our these matrices, like boxes. So for that, I think what we can do is see if we have a box every time, or we can create a set. So either we can add a check here, or we can just iterate one more time to, but I think this one would be better to just go for if we have a, let's just get x offset. Offset is equals to row divided by 3. Y offset is equals to column divided by 3. And then if we have string x offset plus string y offset in subbox sets, then it's okay. Otherwise, like just do not in this. Then we will just create a set. sub box sets. We'll create a sub box string. Let's call it. This is a unique identifier for identifying our sub boxes which we are working with. And then we can check if our element is a dot element. So let's also define element as board, row, and column. If element in row sets, row, or element in column sets, column, or we can also check like if it's in the sub box or not. So we'll just go sub box sets because now we know that this sub box string thing exists. Element in sub box sets dot sub box string. Then we just return false. Otherwise, we insert it in all of these things because always remember to update your variables after you've checked them. Dot add element column set column dot add element and then sub box sets dot sub box string dot add element. So now we have the element in all the correct places, and then we can return true because we have not seen any error till now. So we can safely assume that it will not happen. And then for this loop, I guess it is okay. Otherwise, like, I don't think we have to push too hard to remove this iteration. Otherwise, we can nest it here, but that will result in another if situation. So it's better. And I guess we can also use default dict. Can I use default dict and Python to create a dictionary of sets such that I can also perform a membership check in that set, like element in row sets row, even if I never created a set for row sets start row, and then when I do row sets start row dot add elements, it automatically creates one. Because if that can work, that will save us this iteration, and also this iteration, that we don't have to explicitly check if it exists or not. We can just create the string, check it, and if then add it. Yes, we can achieve this. Let's try it. Default dex. And first, we should like validate our concept by just running this. Okay, it is giving an error, which is okay, happens. Let me just drink some water. Now we have to troubleshoot where the error is happening. We are returning false, but for which element we are returning false. So print, let's just print the row. Let's use the if string. We can print the row. We also print the column. And we also print the subbox string. I want to see which box is causing an issue. So row 0, column 3 here. Subbox string is this. So did we not check? Okay. So first thing we have to check is if element is dot, then continue. Elif do this. Now let's try again. That works. We'll just try to submit this once. See if the logic is correct. The logic is correct. We're creating basically 1, 2, 3 dictionaries and then checking. And we are like, in terms of space complexity, we are creating 3 dictionaries with 9 sets each. So like total of what? 9 into 3, 27 sets. Each one with the maximum of 9 elements. So this also stays constant. We don't increase that. And then membership check on a non-existent key creates an empty set and sets it to false. Then we add it and then it operates on the auto-created set. And this time it will set it to true. So let's do that and let's see how that works. From collections, import default dict. I think I wrote that correctly. And then we create dict, default dict this time. And then we have to set it to like a set, that it will be a set. That saves us from doing this part and this part. I think we can also like do something about this. Like ideally we should not be doing the string thing. It should be something more intuitive. Let's cross this. So another way to approach this would be to just go add them, but in adding them, the two sets like this and this can overlap. So we need to avoid that as well. Let's go with that for now. So if I run this, yep, that works. And still the like timing is slow, but I guess we saved on some iterations. We are creating sets. I guess we are doing more complex operations here. And this is extra thing that's happening. But overall, if like the iterations are more important, we can reduce them. We just go over everything once. So it's just like, iteration wise, we just go of 81. And then for the access and stuff, we go like, ideally, these are sets and dictionaries. So there should be constant time of 1. So overall time complexity for us stays of 1. And then I guess if we put this part, if element is this here, that can also save us some time because most of our elements are going to be that. So if element is this, then continue. And then otherwise, if it's not that, then we can do all the rest of the operations. Let's try if that makes any difference. Also, I like to do this separate thing where I like, if it is very long to read and I have to reuse it again and again, I just separate it because otherwise, if I need to make any changes to this, I need to change it multiple times. But now I have it in a variable which I can easily reuse throughout the rest of my code, which makes just like my life simpler. And I like that. So we have a basic working code, and then we have a little bit more optimized code with, you can say, optimal approach. We are just creating sets. You can also do this using like binary operations, ors and ands, but that overcomplicates things, I guess, for this simple case. So I guess this is a good enough solution. And I think this was a nice stream for today. I'm starting after quite a long time.